Hello students, today we are going to see some more interesting and important questions from Narendra Avasthi sir's physical chemistry, redox reaction. Come on, let us discuss few more questions from this session. In that first question, ratio of moles of iron 2 oxidized by equal volumes of equimolar KMnO4 and K2Cr2O7 solution in acidic medium will be. Right now in the question very clearly it has mentioned they are asking about the ratio of moles of iron 2 oxidized by equal volumes of equimolar KMnO4 and K2Cr2O7. So here KMnO4 moles and K2Cr2O7 moles, how many moles it has? That means number of moles, number of electrons change. N factor they are asking about the ratios. Now this is oxidation process. Fe2 plus it is oxidation process, and KMnO4 and K2Cr2O7 it is a reduction process. You know very well. Right now here KMnO4 and K2Cr2O7 it is a oxidizing agent. Right now this is a reduction agent. Okay, reducing reagent. Right now here very clearly I just bring the point for you to remember and understand. In the acidic medium they mentioned very clearly acidic medium, both KMnO4 and K2Cr2O7 acts as an oxidizing agent. That is what I just mentioned. So Fe2 plus is converted to Fe3 plus, so it is oxidized. Oxidized means it is a reducing reagent. So KMnO4 and K2Cr2O7 it is an oxidizing agent because it is the process, it is reduction, so oxidizing agent. And the same way oxidation, it is a reducing reagent. I hope you got that idea. Now the next point what it is, we have to identify the N factor. So N factor it is nothing, number of electron change while doing the process. So KMnO4 with the Fe2 plus ion and K2Cr2O7 with the Fe2 plus ion, right? That is what I just mentioned. So number of electron change, that is N factor only we have to identify, that is called ratio of moles they are mentioning. Right now here KMnO4. So KMnO4. So KMnO4 like ionic change it is MnO4 we can take it. So MnO4 minus it gives actually what it is Mn2 plus. Right. So MnO4 minus converted to Mn2 plus. Now already I mentioned in these many videos how many oxygen is there in the left hand side, that many water molecules in the right hand side. So how many are there here? 4 oxygen molecules. So 4 H2O. How many hydrogen is there? That many H plus ion because it is an acidic medium. So 8 H plus ion. So now we have to identify number of electron change. How many number of electron change? Here what is that oxidation state? Here minus, no. So this is X plus here 4 into minus 2 equal to minus 1. Right now X plus minus 8 equal to minus 1. So X equal to what it is? X equal to plus 7. So this is plus 7. So this is actually plus 7 oxidation state. Now here plus 2 oxidation state. So plus 7 to plus 2, number of electron change what it is? N factor equal to 5. So 5 electron change. So number of electron change it is 5. So we can put it 5 electrons. Okay, now in that what it is? Fe2 plus ion. Fe2 plus as converted to Fe3 plus. Right. So this 5 electrons, no, this 5 electrons which is multiplied with 5. So this one, what we are going to, what it is, this is KMnO4 which is reacting with Fe2 plus ion. No? So naturally you will be getting what it is? 5. So here also 5. So that means number of electron change, that is N factor. N factor, that is number of moles also we can say. What it is, N factor also we can say, number of electron change, valency factor, that is also we can say. Okay, so there are so many names are there. Here we can identify number of electron change. So number of electron change. So number of electron change in that N factor, right? So this is 5 electrons. So that is what I just mentioned here clearly. So what are the points to identify? So KMnO4 number of electron change, it is 5. Okay, 5 electron change. So I just mentioned here. Now the second one, here we just keep it as it is. Now we just mention very clearly because for the calculation we need this data. So number of equivalent, right? I just mentioned here number of equivalent, number of equivalent of Fe2 plus equal to number of equivalent of MnO4 minus. So here actually what it is, Fe2 plus is converted to Fe3 plus. So that means how many electron change over here? Here n factor equal to 1. But here n factor equal to what it is? 5. So this is multiplied by 1 and this is multiplied by 5. So multiplied by 1, it is same. That is what I just meant. I did not mention in that place. Okay, now here what it is and this point. So here we can keep it N1. Why I'm mentioning no N1, N2. So this is actually N1 into 1 equal to N2 into 5. Why I just mentioned N1 into 1 and N2 equal to 5. N1, it is number of equivalent of IN2 plus. N2 equal to number of equivalent of MnO4 minus. So this is 5 electron change. This is 1 electron change. So N1 and N2, we can keep it as a equation 1. Please remember this because K2Cr2O7 also it is available. We have to compare and we have to find out the ratio of the moles. That is what I just mentioned this point. Okay, now the same way, K2Cr2O7, K2Cr2O7. So in that ionic point, we can bring it Cr2O7 2 minus, right? So Cr2O7 2 minus converted to Cr3 plus. So here in this point, how many oxygens are there in the left hand side? That many water molecules on the right hand side. So that means here 7H2O. So 7H2O means how many H plus ion? Because this is acidic medium, no? So this is 14H plus ion. Okay, 14H plus ion. Now, in that point, oxidation state, we have to identify now. So that means here 2X plus 7 into minus 2 equal to minus 2. So oxygen, it is minus 2 now. Right now, here what it is? 2X plus minus 14. Right, minus 14 equal to minus 2. Right now, here what it is? 2X equal to 14. Minus 2 equal to 12. Right. So that means 2x equal to 12. So that means x equal to 12 by 2, it is 6. So x equal to plus 6. X equal to plus 6 oxidation. So here plus 6, actually this is what it is, plus 6 oxidation state. So plus 6 oxidation state which is converted to plus 3 oxidation state. How many electron change here? How many electron change? So number of electron change, it is 6. How do we get 6? For one chromium atom, it is 3. So 2 chromium atoms are available. So that means here n factor. So n factor of chromium, it is K2Cr2O7, it is 6 plus 6, right? Now the same way Fe2 plus, which is converted to Fe3 plus. So that here n factor, number of electron change, it is n equal to 1. Right now here, as we mentioned above, here also we can mention to calculate that ratio of the moles. Right now here we can keep N3 and N4. So how do we keep N3 and N4 for whom? Here number of equivalent. So number of equivalent of Fe2 plus is equal to number of equivalent of Cr2O7 2 minus. So that means here N3, we can keep it number of equivalent because it is Cr2O7 2 minus with Fe2 plus, right? So here N3 into number of electron change, it is 1 is equal to, and the same way N4 into number of electron change, it is 6, right? Okay, here 6. How do we get 6? Here number of electron change, n factor we have identified now. So that how many electron change? Here number of electron change, 6 electron. How do we get 6 electron? Here Cr2, here 2 Cr. That means per atom it is 3. So 2 atoms are available. So naturally it is 2 3s are 6. Right now here in this point, the same way here we can multiply with that 6 only. 6 electron, multiply with 6 electron, and the same way here also multiplied with 1 electron. Okay, 1 electron, the same number only we can get it. That we have already mentioned in many videos, in previous videos and all. Okay, now let us go for the ratio of the moles. So ratio of the moles of Fe2 plus ion. Fe2 plus ion. Right. So here what it is? Equation 1. So this is equation 2. We can keep it. So this is equation 2. Equation 1 already we have mentioned there, and this is equation 2. Okay, now equation 1 by equation 2. Equation 1 by equation 2. So what is it? Equation 1, that is actually N1 into 1 by N3 into 1, isn't it? This is equal to N2 into 5 by N4 into 6, right? We got that only, no? Equation 1, that is N1 into 1, N2 equal into 5. That is what, no? Equation 1, I just mentioned N1 into 1 electron is equal to N2 equal to 5 electron. The same way, equation 2, N3 into 1 equal to N4 into 6. That is what I just mentioned here. N1 into 1 equal to N2 into 5. And the same way, N3 into 1 divided equal to N4. So this and this will be cancelled. And this one here, equimolar and equivolume, they are asking, no. So equimolar and equivolume, equal volume, right? So equal volume and equimolar, just we bring out molarity. So molarity equal to number of moles by volume of solution in liter, right? Now that means N2 by N4. What is it? N2 by N4? N2 by N4. So N2 by N4, it is 5 by 6, right? That is what we mentioned here, no? So N2 by N4, 5 by 6. We got that idea. Right now, 5 by 6 means ratio of the moles 5:6. I hope you got the clarity. How do we identify this point? It is actually simple. If we know the number of electron change only, we can identify directly. But you should know, if suppose any other question comes, you can use this method. That is what I just bring N1, N2, N3, N4, because two points they mentioned, equimolar and equivolume of K2Cr2O7, KMnO4, both they have mentioned. Only one point, that is Fe2 plus oxidized. This you know very well, right? So this is actually n number of times they asked the same question, but in the one question now we have identified. I hope you got the clarity about that this question completely. Yeah, come on, let us go to the next question now. Which is the correct option as we observe all these points? Now 5:6, number of electron change, and KMnO4, that is 5 electron change, and number of electron change in K2Cr2O7, that is 6 electron change, with the point of Fe2 plus ion converted to Fe3 plus, that means oxidized, and ratio of the moles, that is 5:6. So which is that answer? So the answer, it is D, 5:6. I hope you got a complete idea about this question. And come on, let us go to the next question. The next question, the mass of the mixture containing HCl and H2SO4 is 0.1 gram. On treatment with an excess of an AgNO3 solution, react with this acid mixture gives 0.1435 gram of AgCl. Mass percentage of the H2SO4 mixture is, and the question very clearly they are asking about what it is, mass percentage of acid mixture, that is HCl and H2SO4, mass percentage. Right, now here in that HCl and H2SO4 reacts with AgNO3, we have to find out the product. Then only we can go further to find out that mass percentage of a acid mixture. Okay, here in that point, here what it is, HCl and H2SO4. H2SO4. This is actually acid mixture. This is combined with AgNO3, silver nitrate solution. So we have to find out the product. Then only we can identify what it is, mass percentage of this acid mixture. So first and foremost here, one truth, H2SO4 do not react with AgNO3. These do not react. You know why it does not react? Even if it is reacts also, you will not get the proper precipitate. And one more thing, this is not redox reaction. Right, now let us check the reaction here. H2SO4 plus AgNO3. It gives Ag2SO4 plus HNO3. So Ag2SO4, it is not a precipitate, it is a solution. Right, now here when we are balancing here, Ag2SO4, no, here 2 and here here you will get 2, right, S balanced. First and foremost, this is not a redox reaction, because sulfur here also plus 6, here also plus 6 only will be getting. Right, now here actually Ag here also. So there is no redox reaction. Whereas here HCl can react with H2SO4. HCl react with the AgNO3, silver nitrate solution. You will get what it is, AgCl. It is a precipitate, a solid content plus HNO3. So you will get that PPT, and this is 100% what it is. Redox reaction. Okay, so redox reaction. So redox reaction occurs in this mixture, in this equation, that means in this reaction, whereas here there is no redox reaction and this is no PPT. Here in this point, no PPT. So this is a basic idea for this to what it is further dealing with this question. Right now, only this one we have to identify what it is. HCl and H2SO4. HCl and AgNO3, it gives AgCl plus HNO3. Okay, now HCl, when it is reacting with that AgNO3, you will get what it is, AgCl. It is a precipitate. So molar mass of here, what they have given, molar mass of AgCl. AgCl, it gives, what is it, molar mass of AgCl here, 143.5 gram per mole, right? Whereas here what they have given here in that question, what is it, precipitate here, what it is, reacted AgNO3 when it is reacting with this acid mixture. So it gives what it is, 0.1435 gram of AgCl. Very clearly it has mentioned. So here what it is, here given mass, here what it is, given mass equal to 0.1435 gram they have given. So directly we can, given mass also we know and molecular mass also we know, so that we can find out the number of moles. So number of moles equal to number of moles of what? AgCl, right? Very good, got it. AgCl. So here number of moles of AgCl, given mass of AgCl by molecular mass of AgCl, right? That is what we are finding, right? So given mass, what it is, 0.1435 gram, and molecular mass 143.5 gram per mole, right? So gram cancel, so you will get what it is, mole. So how much mole when you're calculating? 0.001 mole. I hope you got the clarity. This is per mole, so naturally it is normal, there is no inverse. Okay, right, now you got that idea, no? Next one, mass of HCl, you know very well. So now we have to find out that mass of HCl. So mass of HCl. How to identify mass of HCl? Moles into molecular mass of HCl. Molecular mass of HCl. So you will get that what it is, how much mass we have taken for this reaction HCl. So here 0 moles, how much we got it here? And this point 0.001 into, this is mole, right? And mass of HCl, how much? 36.5, right? That is 36.5 gram per mole, right? Now here what it is, so this is actually mole, no? So this mole and this mole will be cancelled. So gram only it will be remaining. So here 0.0365 gram. So mass of HCl with this reaction. So what it is, 0.0365 gram. Okay, now total mass of the mixture they have given in the question, no? Total mass of the mixture. Total mass of the mixture. Total mass of the mixture, how much? It is 0.1 gram. In the question it has mentioned. So mass of H2SO4, what it is? Because they have mentioned it is a mixture of H2SO4 and HCl. So you have to separate H2SO4 and HCl mass. So mass of H2SO4 is equal to total mass minus mass of HCl. Mass of HCl. I hope you got the clarity, because it has mentioned it is a mixture. H2SO4 do not react with AgNO3, so that we are leaving that. But even though if it is not reacting also, it is a mixture they mentioned, so we have to what it is, separate that H2SO4 mass, right? So naturally the mass of H2SO4 equal to what it is, total mass 0.1 gram minus HCl mass, what it is, 0.0365 gram. So naturally how much you'll be getting? You'll be getting 0.0635 gram. So mass of H2SO4, in that what it is, 0.0635 gram it has mentioned. Now percentage of H2SO4, we are going for giving the answer percentage of mass of H2SO4. In the question, it has mentioned percentage of mass of H2SO4 only, right? So percentage of mass of H2SO4, that is mass of H2SO4 divided by total mass of that mixture into 100. Okay, now this is mass of H2SO4 divided by total mass of compound, that is mixture. Okay, mixture HCl and H2SO4 into 100. Okay, so now what is the answer you'll be giving? 0.0635 gram, right? 0.635 gram divided by 0.1 gram into 100. So how much you'll be receiving? You'll be receiving 63.5%. So the mass percentage of this H2SO4, mass percentage of H2SO4 in that mixture. Now we got that idea, 63.5%. Remaining HCl, so 63.5%. It is actually H2SO4 mass percentage. When we are asking about HCl, so 100 minus 63.5, so you will get the answer for HCl mass percentage. I hope you got the clarity about this question. Now how to identify according to that step-by-step reaction with that. So first and foremost, HCl and H2SO4, when we are talking about reacts with AgNO3, AgNO3 do not give redox reaction with H2SO4. So H2SO4, it is actually, what is the product? The silver sulfate. It is not actually a precipitate. It is a solution instead, and moreover, that is not what it is, redox reaction. Only HCl, what it is, HCl reacts with AgNO3, you will get AgCl. That is only the redox reaction, and you will get the PPT also. AgCl, PPT also they have given, and AgCl gram only they mentioned in the question also, right? Fine, got it. So now I hope you got the clarity now, which is the correct option. The option 63, right? 63.5 mass percentage. So this is the percentage. I hope you got the clear idea about that. So HCl, if they are asking this one, 36.5 and 50, it will not be possible. And in none of this, it is not possible. I hope you got a very good idea about how to solve. See, suppose some other question related this, values may be vary, but concept it is same only, right? Come on, let us go to the next question. Next question. A solution of Na2S2O3 sodium thiosulfate and standardized iodometrically against 0.167 gram of potassium bromate. Right. This process requires 50 ml of sodium thiosulfate solution. Now, what is the normality of sodium thiosulfate? Generally, what do you mean by normality? Equivalence divided by volume in liter. Okay, now here they have mentioned about thiosulfate only. No, so sodium thiosulfate, it is 50 ml. Right, now we have to convert that is 50 ml to liter conversion. And one more thing here, what they have given a solution of sodium thiosulfate as standardized iodometrically against 0.167 gram of potassium bromate. So this process, so that is what here they mentioned very clearly, iodometric titration. So iodometric titration, potassium bromate acts as an oxidizing agent in the acidic medium. So very clearly it has mentioned. Okay, now here in this bromate ion reduces bromide ion, right? Now let us write the redox reaction, half reaction. Here it is BrO3 minus reduces to Br minus. So here in this, how many oxygens are there? That many water molecules. How many hydrogens are there? That many H plus ion, because it is an acidic medium. Now, how many electron change? So we have to find out the oxidation state. So here we are finding that is plus 5 oxidation state. Here minus 1. So plus 5, which is converted to minus 1. That means number of electron change, it is 6. Right? Okay. Now that means here N factor we can bring it. Number of electron change is also known as N factor. So N factor of BrO3 minus, right? So that is potassium bromate. Okay, I just mentioned KBrO3. So this is actually 6 electron. Right, now we got that idea. The next point what we are going to bring, it is actually number of equivalents of potassium bromate. Number of equivalents of potassium bromate, KBrO3. Okay, so that is actually what it is. For what formula can we use? Mass, that is given mass divided by equivalent weight. So equivalent weight, what it is? Molecular mass by N factor. So that is given mass, that is given mass here also. This is the formula, equivalent number of equivalents of such compound, that is given mass divided by equivalent weight. So given mass divided by equivalent mass. How to identify? Molecular mass divided by n factor. Right, n factor of KBrO3 only, we just found that, right? How many number of electron change? It is 6 electron. Okay, come on, let us apply the values. So given mass, what it is? Given mass actually 0.167 gram divided by, here molecular mass of KBrO3, here 37 and here 80 and here 16 into 3. So 48. So altogether it is 167 gram per mole. Whose molecular mass? This is KBrO3. So here equivalent weight is what it is? Here equivalent weight, that is molecular mass by n factor. So molecular mass, it is 167 gram per mole divided by n factor 6 electron. Okay, let us write like this: 0.167 divided by, that is gram, divided by molecular mass 167 gram per mole. Here this 6 electron will go upwards, so automatically you will get what it is? 6 electron will come over here. So what is the answer you'll be getting? You'll be getting around 0.006. Right, you will get that answer. Right, okay, so that is equivalence. Equivalence only we are finding, no equivalence. Right, now next one, equivalence of potassium bromate, KBrO3. Right, this is only 0.006. Right, now next one, what we are going to find? Normality. That is the main point. Normality, what they mention? Normality of sodium thiosulfate, Na2S2O3. So Na2S2O3, now what is the formula? Can we use it? Equivalence divided by volume in solution. Equivalent divided by volume in liter. Right, so here equivalence, that is 0.006 equivalent. Right, now volume in liter, so that is 50 ml they have given. No, make it a liter, so 0.050 ml. Right, okay, come on. So here given volume of solution, that is 50 ml, right? That is for sodium thiosulfate only. Given volume of solution, it is Na2S2O3. Okay, so I hope you got that idea. So conversion into liter, that is 0.050 liter. Okay, now let us apply this formula: equivalence divided by volume in solution. So equivalence, how much we got? 0.006 divided by volume in liter, that is 0.05 liter. So how much you will be getting? Around 0.0 won't be coming. 0.12 n. Right, normality. So normality only we are finding, right? So this is normality, no? Normality of sodium thiosulfate. So normality of sodium thiosulfate, Na2S2O3, 0.12 normality. I hope you got the clear idea about this point. Yeah, so in the two main things we have to identify. First and foremost, what we have to identify, that is number of electron change in that half reaction. Then equivalence of that potassium bromate, because potassium bromate only that we are going to find, right? So when we are finding the number of equivalence of potassium bromate, then easily we can identify that normality of sodium thiosulfate. Okay, I hope you got that idea. Now, which is the correct option? 0.12 normality of sodium thiosulfate. Yes, you got it. Yes. So the option, it is B. I hope you got that clear idea. Come on, let us go to the next question in our next video. Until then, thank you for watching.